Welcome to Software Engineering Daily. I'm your host for today's episode, Joe Nash, and today I'm joined by Dr. Sybren Stüvel. Sybren is a developer at the Blender Institute, where, amongst other things, he leads he leads the work on the animation and rigging module. Welcome, Sybren. Thanks so much for joining me today.
Oh, thank you for having me, Joe. It's a pleasure.
Well, so before we get into, I want to get into your background and your journey into Blender, but for folks who are listening to this who are unfamiliar with Blender, I want to start with a really brief intro. Could you tell us a little bit about, what Blender is?
Well, Blender is basically a big 3D workhorse. So you can do modeling, but you can also do sculpting. Well, it's kind of a way of modeling, but you can do sculpting, you can do texturing, but also animation, rigging, of course. And it basically is a full pipeline. So you can also do video editing in there, and you can render out. It has different render engines that are aimed at different kind of looks and different techniques, which lead to different rendering times. And so it really allows you to start from scratch from an empty 3D world and end up with your own film.
Perfect. Awesome. Yeah. So we'll come back to a lot of those topics in due course. But first, I believe you've been working with the Blender Institute for a real long time, or you've been surrounding Blender even longer than that. Can you tell us, how did you get first involved with Blender?
Well, before that, even I started using Blender myself. Before that, I was dabbling a bit with Lightwave, which I really enjoyed. And back then, Babylon 5 was on TV, and they used Lightwave actually for all the space shots. So the ability to recreate those spaceships in your own computer and make your own little videos with it, that was fantastic. Especially because they didn't do that much in terms of texturing. They just used the built-in like Voronoi textures and that kind of thing. So you really could make it look like the TV show, at least back in the skill level that I had back then. For me, it looked exactly the same, which was fantastic. And so Lightwave was it was kind of special because it had different modes. You could, I think it was tab or enter or something. You press that, and then you get, instead of like arranging your scene, you were starting another app that allowed you to edit your model. That I found really useful because then you're like free of all the clutter of that entire scene, and you could just polish that model. And then with the same key, go back to your entire scene again. And so after that, I tried 3D Studio Max, which drove me absolutely bonkers because it doesn't have that. And so you're working on your model, and all of a sudden you selected some object in the far background, and now you're working on that. And then I hear news about this Blender thing that was just struggling to become open source. So it was actually one of the first crowdfunding campaigns on the internet that made it possible for Blender to become open source. I didn't know about the history before that, but by now I do, of course. So Tom Roosendaal, the founder of Blender, he has had a few different companies in the past, and that last one where he made Blender, that actually went bankrupt. And so all the possessions of the company were then owned by the investment company. And basically it was a crowdfunding campaign to get, I think by heart, like 200,000 euros in order to pay the investors, and they would then agree to release Blender as open source.
Sorry, just to jump in. So what kind of year was that? Just to get a scale of, what the 200,000
This was 2003.
2003. Okay, awesome.
Yep. And so that's where I first started using Blender, and that again had these edit mode and object mode. And so you could, like, what I liked so much about Lightwave, I found back in Blender, except then it was actually legal for me to use it. So that was a nice bonus.
Excellent.
In 2004, I filed my first bug report. And that was pretty much for years my involvement with Blender, until I did my master in game and media technology. And there we had a course about 3D modeling, and one of my fellow students, friend of mine, told me, like, hey, listen, that Blender is in Amsterdam and we can visit. They're working on a new short, and on Friday we can actually visit. So of course we did, and we rang the doorbell. Tom Roosendaal opens the door, big smile on his face, welcomes us in. And that is the first time that I actually saw the Blender Institute. And yeah, it was amazing. It was fantastic. The atmosphere was really good. There were people pranking around. They were working on Sintel at the time. And every time the rigger got his hands on the model, he changed the color of her eyes, which was hilarious. So fast forward a bit more, I've done my master and I'm working on my PhD. That was doing crowd simulation. And I wanted to do that in the Blender game engine, because then you could record the movement in the game engine of the simulation. You could record it to animation data, go back to Blender itself, and then replay what it recorded. And that was a really useful tool for me as a developer to go back to the point where it started going wonky, and then trigger that particular wonky crowd agent to explain its reasoning. And because all of that was in the same environment, that was super convenient to work with. But Blender couldn't do what I needed to do. So I needed information about collisions between those agents, and I wanted to know where exactly that collision was, and Blender did not give me that information. I knew that because Blender was using the bullet framework underneath, I knew that that information should be able to like, it was there. I knew the framework would give it to me. And that was actually my first functional patch that I sent in to Blender to get that info out there.
Nice.
After a few patches, I started nagging more and more, like, hey, is it in yet? Is it in yet? Poke, 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 poke. Is it in yet? And then they got annoyed by me, and it was like, here, you have your own commit access now. You just do it yourself. And that is how I became Blender developer. So before working there, I was already helping out with the project. There's also the yearly Blender conference. And since 2011, I've been to every one of them. Of course, being a student, I didn't have much money. And back then, you would get your ticket for free if you had a talk. So I made sure that I had a talk. So I think since then, I've never paid for more than 2 conferences, I think, because I wanted to be like part of that community and part of their part of the life there. And that, again, for me was a big influence in wanting to work at Blender, because it was so pleasant and so full of energy, and everybody was so happy about seeing each other, about working with Blender, and also seeing the mixture between Blender developers and Blender artists, all at the same conference, mingling with each other, getting inspired by each other. That was a fantastic atmosphere.
It sounds fun.
And so, yeah.
What a journey.
And so I started going to more and more of these weeklies and massaging Ton more and more about, so that he understood what I had to offer and that I really wanted to work there. And in the end, it worked out. So since 2016, I'm working at Blender Institute, first as a web developer, because then Blender Cloud was just there, I think, for a year or so. And that was a source of income for the studio, because that is what it was built for, to provide a more stable income source for the animation studio. And so because I could do web stuff, I could start working there, and slowly I maneuvered myself towards more and more Blender development. And that's what I do all the time now.
Perfect. Yeah, and so I want to talk a little bit about that maneuvering. First of all, amazing showcase of where committing to the software that you use to scratch your own itch can get you. That's really fantastic. So you now, as we mentioned, you lead the animation and rigging module. Did you end up in that space because of the work you've done in your master's or PhD, or was this like another unrelated journey?
No, it is related, and it's not a coincidence that I did my master's in that area, because I really enjoy animation. I love watching animators work. I'm not that good at it, but I love seeing them work, and seeing from like a character that is in walking stage and is just moving from A to B, to seeing an actor, like something with a soul and a motivation behind that movement, to go from A to B and see that come to life. That I feel it's still magic.
Yeah.
So being able to participate in that process and being able to help people achieve that, I think it's really nice work.
That's wonderful. So I want to dig into, you mentioned a bunch of Blender features at the beginning, from the modeling to the sculpting to the various rendering techniques. I want to dig into a little bit of what Blender enables people to do, and I guess one area that I would like to start. Oh, I guess actually to take a kind of a holistic view. Say like I'm creating a short film on Blender and I'm doing the whole pipeline in Blender. Like, what is the sequence of features that I'm going to use to put that together?
Oh, if you're really enticed to do everything in Blender, then I think you would start with Grease Pencil, and using that to create storyboards.
Okay.
You may want to do that still on paper because it's less tempting to start making things pretty, and at that stage, that is very important that you keep things ugly and very, very fast to iterate over. But you can use Grease Pencil for that, for sure. Then you may want to cut that up into sequences and shots and start planning out those shots. Start building temp everything. So temporary sets. Make an inventory of which locations do we have, what do they look like, what do they feel like. Build those sets, build your characters, design your characters. Probably, again, might not do that in Blender, but rather in Krita or pen and paper to just start on the design of the characters and the look depth, basically.
Sure.
And from then, I would say start building stuff and blocking, like making more proxy objects that you can play around with in 3D space so that you can work on layout. Maybe start splitting up files into different blend files that you can link into the shot file, and then add some overrides on top so that you can move things around. And then you can play with your storyline, and you can slowly start replacing those drawings you made for the storyboard and replace them with actual 3D rendered, ugly looking, super plain, boring, low poly stuff. And then you can draw the rest of the owl.
Yeah, of course. Yeah, yeah, absolutely. So yeah, speaking of some of that, drawing the rest of the owl. Obviously, what you work on is animation and rigging. So I think most people I know have at this point, played with modeling tools on Blender. We all did the donut tutorial during the lockdown, and I haven't got as far as animation and rigging. Like, what are some of the tools and like toys available for content creators and developers in there?
Well, one, like the most important tool is, of course, setting a keyframe.
Okay.
So you can key pretty much anything in Blender. The current incarnation of Blender's animation system came from Blender 2.5. So that was years ago. But like their big shift was to make everything animatable. Okay. Instead of only these specific properties that were opened up for animation. Everything was animatable except where it had a flag that would prevent that.
Okay, so pause for a moment and dig in. Folks who haven't been in Blender, like what does that mean? Like, what are the things that are animatable that like might be unexpected from before that transition?
Oh well, pretty much all material properties can now be animated, but there is also like visibility properties of things can be animated. So you can animate a cube that hides and unhides, and that is still one of the more annoying things to animate at the moment, because of like the reasons.
So I guess that's more than an opacity shift, right?
So you were saying it's more than just an opacity slider,
right?
And that is true. Like when you animate the actual visibility of an object, there are other things come into play because you cannot select it anymore. You cannot see it in your 3D viewport. And that means that if it were still selected, you might influence it. You might select another object and start moving things without knowing that you still have that hidden object also selected and also moving around. And so that is one of the usability rules that we have in Blender, is that when something is invisible, you shouldn't be able to manipulate it.
Right.
Which works out pretty well in most cases, except for when you want to animate the visibility of that object, because then once it's invisible, you cannot select it anymore to make it not invisible. There's ways around it, but it's a bit annoying. So that's one of the things that we have in mind while working on newer animation stuff. So what I was saying, like you can hover over any property in the properties panel or in other areas of Blender, press the I key on your keyboard, and that will set a key for that particular property.
Amazing.
And you can change time, hover over the same thing again, press I again, and then you can manipulate things over time, aka animate. Other tools that we have are auto keying. So you press a record button, and then when you move things around in your scene, that will automatically key them. And so you can pose your character, go to another frame, pose it, go to the next frame, pose it again. And you don't have to hover over whatever property you want to key. You don't have to press the I button. You don't have to do anything. It will just record everything. And for many animators, this is their go-to default, because they don't want to think about keying particularly. They just want to think about character actions and animating things instead of the whole technical part of creating those keys.
Yeah, that immediately took me back to warm, fuzzy Flash animation land. Like, that made me very happy to hear that. That's
yeah. And I would say another important tool that we have, which is also very trivial for anybody who has done animation, but I just want to mention it, is the interpolation options. So every key can say what happens in the span of time until the next key. And that means that you can have a linear interpolation, or that just goes from A to B in a straight line. By default, that is a Bezier curve, so it smoothly goes from value to value. When you're trying to look at your rough animation, that is super getting in the way, though. It looks nice. It looks super smooth and like you've done a great job. But the problem is that you never know when you're looking at a key that you set, and when you're looking at a key that it was generated by Blender simply because it had to go from A to B. And so that is also like the blocking that I mentioned earlier. That refers to the shape of the graph editor. When you start blocking out your animation, you set all the keys to constant interpolation. And with that, you only see those poses that you made yourself. And it makes it a lot easier to see how dense those poses are, what the sequence of them is, how they fit well together. And if you don't do that, your animation will just be floating around in space, and it's very hard to see what you're doing. So that's a few of the tools. I mentioned the graph editor that shows all these properties and how they change over time. We have the dope sheet that doesn't show how those properties change over time. They just show the keyframes. So if you want to have a bit more, like a different overview, that's a little bit cleaner. That allows you to show bit more keyframes on view for retiming purposes and that kind of thing, then the dope sheet is really handy.
Awesome. And so I guess that's on the animation side. And then when it comes to, I guess, like things like character rigging, so I have a very only like passing understanding of rigging from, a little bit of game dev experience, but what goes into character rigging for Blender?
Well, I think the armature is pretty standard in character animation. Not all 3D animation software actually uses armatures in the way that Blender does it. And I think the way Blender does things is quite good. So what you would do is first you would create your model and have that like in a T pose or an A pose or something that is easy to rig up, so that like the left arm and the right arm are in the same pose. And then you create the armature. That basically is a thing that consists of bones, and those bones, they connect to the mesh. So by default, the closest bone is connected to like that part of the mesh, and they have a nice fall off to the next bone influence. And this allows you to just rotate a bone that takes along, just like real characters, takes the flesh and the skin along with it. And that saves you a lot of time in animating, because you don't have to move every vertex of your mesh by hand. You can just move them as one group and just manipulate those bones. And that is what is called the deformation rig, or the deformation armature. And that is just moving a bone moves part of that mesh. Now, this is not always the best way for an animator to work. Mm-hmm. So what you typically put on top of this is more bones with like some custom shapes so that you can distinguish them and they can be shown outside of the body instead of always being inside. And those are that's the control rig, basically. Mm-hmm. And those can have more smartness in them that allow you different ways of moving. So by default, those bones move in a forward kinematic way. So that is, you rotate a bone, and then all its children that are connected to it just rotate along with it in unison. Mm-hmm. And this is great for like a waving motion because you only have to like rotate the underarm and the rest of the hand goes along with it. But for putting a hand somewhere to pick up a cup, for example, it's much easier to grab that hand and then let the other bones rotate so that that hand follows your everything. And that is called inverse kinematics. And with Blender as it is now, you need to set up like different chains of bones for forward kinematics, for inverse kinematics, and have some way to switch between the two, snap one to the other. So that gets a little bit more complex. Fortunately, Blender comes with a tool called Rigify, where you can just say, I want to have a standard human. And that creates a whole set of bones for you that you can then scale and adjust and move around so that it matches your character model. And then once like you've basically told Rigify what your character looks like, you click on a generate button and then it creates all the switching between forward and backward kinematics, turning on and off different layers. It adds more detailed control to the face that you can turn on and off. So when you're blocking, you just have that hand motion. When you're working on face animation, you can turn on the things that you need at that time. And that is a quite nice way to start working with animation. And that takes away a lot of the complexities of this.
Yeah. I have so many questions about how that works and how that generation works. I don't know how this starts. So I guess like one thing I'm very curious about is like how the deformation between like, you know, the actual model and the armature works. So like how the armature is attached to the mesh, like in the implementation wise. Like how does, I guess it's just like moving vertices, right? Or like translating vertices.
It is. Interestingly, it was in, I think, 86 that there was a paper about, that was the first paper about skeletal animation. Mm-hmm. And that was specifically made for hand animation so that you could put bones in the hands and then the vertices come along with it. That was, that is still basically the technique that we use now. Cool. Which is quite interesting.
Yeah.
So what you do is you divide you assign every vertex to one or more vertex groups. Mm-hmm. So in your mesh, and Blender can do this automatically for you, but the end result in your mesh is that you have a vertex group for every bone, which is just mapped by name. And every vertex in the mesh can have a certain weight. Mm-hmm. So it can be influenced by that vertex group for 100%, or it can be in that vertex group and that one both for 50%, and then you get like a smooth fall off.
Interesting.
And then when a bone moves, it has a certain transform between its rest pose and the current pose. That could be move 1 meter to the left or rotate by this amount, usually a combination of the two. Maybe some scaling involved. And it's that transformation that brings it from its rest position to its current position that is then also applied to all the vertices in that vertex group. And by doing all of that, you have your deformation. That's how everything moves along with it.
Very cool. So when it comes to the... Sorry, go ahead.
This is also something that we want to address. Like we, probably not in the next year, probably not in the next year and a half, but maybe after that. Because I just said, like, we have this rest position of the armature, and then you have the current position. And that rest position, there's only one rest position currently in Blender. And that means that the way you model your character that is how you put your bones in the mesh. That is the rest position of your bones, and that is also the reference position for all animation. And this doesn't necessarily have to be the nice way to go. For example, when you make a 3D scan of an actual person, no way that they have their arms exactly in the same, like mathematically exact in the same place, but then just mirrored. No way that they're mathematically perfectly symmetrical. Even if they were, 3D scans are noisy, so their output model won't be. So, and also for animating, it helps when the rest position is like axis oriented, so that the arms are really going straight left and right. For a 3D scan, your scanned model will stand much more comfortably when the arms are a bit more like an A position. Also for deformations, that might actually be a better starting point. And that means that we want to have different rest positions. One where you have the binding pose basically for the mesh, where all the bones are in their neutral position, where they can be bound to the mesh. And then another pose where you can just move those arms in perfectly straight axis aligned orientations and have that as the reference pose for animation.
Understand.
And yeah, that's like one of the things we really want to work on at some point.
Interesting. Okay. Cool. Yeah. Thank you for scratching that itch I've had for a very long time.
Yeah.
So the other thing I wanted to ask about is, you mentioned like forward kinematics and inverse kinematics there, and that's another area that I think lots of people have heard of, but would be really interested in how the calculation of like, okay, I've moved this bone, how is that transform rolling forward or backwards, as is the case? Like, what is the algorithm that kicks in there to make to make those translations occur between those bones?
Forward is very simple.
Okay.
It just every bone has a translation, which we call location in the interface, but mathematically speaking, it's a translation, a rotation, and a scale. Those three are combined in the right order to form a matrix, and so every bone has a transform matrix. And forward kinematics is just multiplying those matrices from the parent all the way to the child, and then you have the final transform of the child that takes into account how all the parents transformed before that, and then you can apply that matrix to the vertex groups, and then you're there.
Cool.
That's going back a little bit to how the mesh deformation works. Yeah. This was one of the two options that Blender currently has. We also have dual quaternion based, which is better at keeping the volume of the mesh constant. Because if you have like a twisting motion like this, like say you have an arm here and you twist it like that.
Right.
If you do it naively, you will get what we call candy wrapper artifacts.
Sure.
You have in the middle, it would just squeeze down to nothingness. And the dual quaternion system works around that. It has some other downsides.
Okay.
But you can switch between.
One of which you have to work with quaternions, but yeah.
Well, you don't have to work with quaternions to use the dual quaternion method.
Fair.
But that was a sidestep from the forward and inverse kinematics. The forward is simple. That is just matrix multiplications. The reverse of that, the inverse kinematics, is way harder because there is an infinite number, usually, there's an infinite number of bone orientations that will lead to the final position of that end effector. And like you can imagine that like when you're holding a cup, that your elbow can be there or there, and that cup is still in the same position.
Yeah.
And so what most inverse kinematic systems do is taking many, many, many tiny steps and then seeing like how does this matrix need to be modified in order to bring the cup to the desired transform. And then taking small, many, 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 many small steps, and then hoping that eventually leads you to the right positioning. But it starts out at the current current orientation. So it tries to minimize how it's moving around. Again, there's multiple options in Blender with different implementations of this algorithm that do or do not take the current orientation into account. But in the end, they boil down to somewhat like trial and error and having a mathematically smarter way of knowing roughly in which direction to go, and then doing that a whole bunch of times, refining the end result.
Fascinating. Yeah, the infinite possibilities of getting that original, the what node you're working back from in position had never occurred to me. That's really interesting. So yeah, to jump to a different area a little bit now. So one of the things you mentioned at the start, again, just like hitting all the questions I had about Blender. So you spoke about rendering at the start and the different rendering, options and rendering modes. So, I've heard the term cycles, and there's more recently there's been Eevee. Can you tell us a little bit about, these two different renderers and when each might be used in Blender?
Oh, sure. So cycles is first of all, little disclaimer.
Yeah.
I'm not a render engine guy.
Sure.
So I might get the finer details of the terminology wrong. Apologies for that. But basically, what cycles is a path tracing render engine. So it shoots out rays of vision basically from a camera. And it just says, okay, what would I see if I look in that direction? And then it shoots a ray in that direction, and it might hit something. And then a bunch of things can happen. It could return, oh, this is blue. That's a diffuse color. We can see that equally from all directions. So I can just say it's blue. Or maybe it also has a specularity to it. And then that ray needs to know, oh, but what is being reflected then in that specularity? So it needs to bounce and continue on.
Mm-hmm.
By the way, also for the diffuse, it needs to bounce and continue on because it needs to know, is this part of this mesh even illuminated? Or am I bouncing off into a black hole where there's only shadow, then it becomes black? Or do you bounce and hit maybe a huge, shiny light box or something? And this is also where it gets a bit tricky, because a diffuse surface scatters in all directions, and you can only try one when you don't have a quantum computer. You can only try one thing at a time. So that means that cycles actually does try only one thing at a time, and it might hit that light, it might not, and that is why when you stop a cycles render very, very early, it will be very grainy and noisy, because some of those rays may have hit that light source and become bright, but the neighbor pixel may not have hit that light source and stay dark. And that is sort of a randomized process. And so the more you send out rays to the same pixel, 10% might hit the darkness, but 90% might hit the light. And then you keep averaging over those samples, and eventually you will end up with what should be the truth. And that is for 90% illuminated because there's a big fat light next to it. And that is why you see that grain when you start rendering with cycles. It starts out very grainy, and then you see that grain dissolve basically and turn into like a pretty image. And the more time you give it, the prettier the image will be, but also the longer your render job will take. And so that's a balance to hit. Also, there's a lot of development in cycles on guiding those rays to the more important bits, so that if you have like a small light source, that it still is able to find that small light source without having to randomly sample everything on the planet, because the light source is very small, so a random ray wouldn't hit it unless it's like exactly on there. And there is like guidance in place to help the system out and speed it up. So that is cycles. It's shooting rays, taking time, getting faster over time as well, and getting really good realistic images, because all the light bouncing and effects like that are being taken into account. And then you have Eevee, which is another render engine that takes a much more game engine like approach. So I don't know that much about it, but it, as far as I know, it does project, like it has a shape in 3D space that it projects onto the screen, and then it knows, okay, these polygons take up this amount of space, so that is why I have to draw the texture there. And so that is much more real-time engine. It is aimed at similar techniques like Unreal Engine is doing.
Sure.
Actually, when I saw the demos of Unreal Engine, I don't know which version was out at the time, I was amazed by it, and it looked so good. And I was like, my God, what are we doing, Cycles? Like, there is this engine out there that can do this in real time, and we have to wait for so long. Yeah. And then Clément came, like Clément Foucault, the creator of Eevee. He came to the studio to demo like early versions of Eevee. I was so relieved because it really helps us to move in that direction as well. And now both are there and both are amazing. There is another render engine called Workbench Engine, and that is actually what you see in Blender itself when you're in your 3D viewport and you don't have it set to render, like show the fully rendered image. So you just see the solid geometry. That's the Workbench engine. You can also use that to just render out an entire film if you want.
Got it. So yeah, that was going to be, I guess, so my question from that was, obviously Unreal, a real-time rendering engine makes sense because, it's a game, you're moving around, whereas like, Blender, it's a movie. So like it's going to be static once you render it to some extent. So when is Eevee used? Like when do you want real-time and a real-time rendering engine in Blender content creation?
Like a very big difference. Like I think even from an architectural point of view, an even bigger difference between Unreal and Blender is that Unreal is optimized for the gamer's experience.
Sure.
And that means that you can have quite a lot of pre-computing going on because a lot of things won't change or will stay within certain parameters because that's how the game was made. And so while you're doing these pre-computations, while the computer is doing that, it can take all those like things into account and optimize things and pre-compute things for you. Whereas with Blender, it's aimed at the creator. Mm-hmm. And so Eevee has to do less. It can do less pre-computing because you can delete that mesh at any one time. You can be modifying that mesh. You can be texturing it. And so it has to respond to that immediately instead of baking everything down into easily accessible stuff for the GPU so that the gamer has the good experience. And that also hints towards like, what is the usefulness for Blender users? Well, imagine texturing while it's being lit and while you have the smoke in there, so that you know which part of the texture are going to be covered by the mist pass anyway. You don't see that much detail. And you can all just paint that in real time versus doing that in a separate texturing application and then bringing it in and then seeing what it looks like.
That makes sense.
So typically, like you can make things in Eevee look really good. If you look at our production Charge, that was made entirely in Eevee, and I think it looks amazing. But also, when I try it out myself, I find Cycles a lot easier to work with because it's just about placing lights and textures and toying around with materials. Whereas Eevee needs a lot more hand-holding in terms of where it can gather reflections, where it can gather other information, like for that it needs that info to stay real time to get fast, and so it needed a bunch more hand-holding to get it to work well. That's my like outside perspective, anyway.
Right. Yeah, no, that was great. That definitely cleared up some of some of the questions I had. So a couple of times you've mentioned, like films that Blender themselves have made, and recently, I think especially this last year, I've seen a lot of attribution of Blender to like larger projects. I think RRR, which is is one that, you know, obviously did incredibly well, but I've seen a special acclaim about for its VFX, and I know that Blender was used in that. So I know that aside from animation rigging, you also work on some projects to do with, you know, large scale render pipelines and that kind of thing. So I was interested in, you know, first of all, you know, what does it take to make Blender useful for, you know, a full feature film like those produced by yourselves or RRR? And yeah, let's start there.
Well, what makes Blender useful is a hard question to answer, because it is useful. People do stuff with it. From a very boring point of view, but you're hitting on like large scale render farms.
Yeah.
Like imagine using commercial software that you have to buy expensive licenses for and manage those licenses. Imagine running that on a big render farm where that you might want to run in the cloud and spin up, spin down different render nodes depending on like whether you need them or not. That's a nightmare. Also, imagine like the purely hypothetical case where for some reason all of your staff, all of your artists have to work from home. They can't work. Like, unless there is an infrastructure that can check that their license is actually valid, they can't do their work if like that license server can't be reached, or they are not allowed to install anything on their home computer. Whereas with Blender, nobody cares. You just download it, run it, and you're good to go. You just need access to your files, and you can always use it from wherever you want. So that is a big advantage, especially when you're looking at like these larger productions. Another advantage of using Blender is that it does a lot of things. Mm-hmm. So instead of juggling all kinds of different applications for different purposes, and making sure that everybody is using the same version of every application and has it working and running on that computer, you can just work in Blender for modeling, texturing, doing inclines. Like, for example, Spider-Verse used Grease Pencil for part of the inclines.
I did not know that. Fascinating. Okay.
If you look at Spider-Verse 2, like many of the inclines were done in Blender, with Grease Pencil, but also the little bit of the like that had the Lego universe. Mm-hmm. That entire scene was made in Blender, actually by a 14-year-old kid. So that is also what I find so inspiring about working on Blender and at Blender. Like, we're putting this tool into so many hands. Mm. We open up so many possibilities for people because it is free and because anybody can just download it and use it and be creative. And it has applications also in the very practical field, like 3D modeling for the 3D printing, for example. So you can start producing things, and it really opens up all kinds of different possibilities for people who otherwise wouldn't have been able to do this. And that is very inspiring and very, very humbling for me as well.
Yeah, absolutely. And I want to come back to that topic in a bit, because I have some questions about accessibility on that. But whilst we're on this topic, so you mentioned render farms. I know you work on another project called Flamenco, which is all about, you know, render management. Can you tell us a little bit about Flamenco and, you know, what its use case is?
Flamenco is the render farm software that we use in the studio, and it has a long history going back to, I think, 2011. Some people worked on a tool called Blender, which was like a Blender render contraction. And Francesco has been working at Blender for a long time. He also worked on that, or at least on the successor of that. After after a while, Flamenco started. It has had a bunch of different incarnations, and that is basically where I stepped in when I started working at Blender Cloud, because we thought it might be a nice idea to integrate Flamenco with Blender Cloud. On Blender Cloud, people could just start their own film production projects and have asset management in there. So the user accounts were already there. project membership was already taken care of. So hooking up some render management tool to that, where the results are also visible on that same web interface within that same project, that was kind of tempting. So we did, and that was a nice tool that worked for quite a while. But we noticed, especially when talking with studios, that they weren't so inclined to use it, because it's always tricky and sensitive when you're using it, like you're using somebody else's tool and somebody else's infrastructure to work on your intellectual property that shouldn't be leaking out until like the thing is actually released. And even though we made it in such a way, like Flamenco is still now, that you could use your own machines for rendering, part of it was still connected to Blender Cloud, and that was like hard to work with on different levels. Also, the part that you would host yourself on your own infrastructure was kind of tricky to install, and it became over time harder because we also didn't have that much time to improve things there with all the other stuff that's going on at the Institute as well. So in early 22, we decided it was time for a new incarnation of Flamenco. We took out the Blender Cloud dependency, basically rewrote most of it from scratch. And in about 7 months, I think, we had a usable version. And it's like, it really focused on getting things up and running as quickly as possible, as easily as possible. Tom also was very adamant about no databases. And I was like, something like Postgres is easy to install. You just do apt-get install Postgres, you press enter, and then like it's done. But we also had the focus on smaller studios and people at home. They should be able to use it. And it's not for like these huge studios, because first of all, there's not that many huge VFX studios out there compared to smaller animation studios. So it was like, it opens up a broader market. We're not selling anything, but still, like, more people can use it. And also it simplifies a lot of things. And so that no databases, I was kind of, Postgres is so tempting and it's so easy to install, until I started installing it on Windows for the first time. And that was hell. Like, so many next. Oh, now you have to make this really important decision that you have no idea what it actually means, unless you really read up and want to be a Postgres maintainer. Then it makes sense. But if you're just somebody at home who wants their renders, like, it's no. So I agreed with Tom, like, no, this is not what we want to do. So now Flamenco uses SQLite, which is like an embedded database engine. You don't even need to have that database file. We'll just start from scratch when you delete it. So Tom said, like, make it as simple as running Blender. With Blender, you can just download a zip, double click on blender.exe, and you have Blender. You have it running. And it should be that simple to get a render farm running. And of course, that's very challenging, because a render farm has to coordinate between all kinds of different computers. So it didn't become that simple. But if you just want to run it on one computer, it actually is. You can just double click the Flamenco Manager exe. It starts up your browser. It gives you an introduction about how it works, what the architecture is. Asks for a few simple things like, where's your files, where's your Blender? And then you have a working farm. I'm slightly simplifying things here, but I did make a video 4 minutes and 59 seconds long. It's on YouTube, and that is like just showing off, if everything goes well, how fast you can get it running on a single computer.
Perfect. We will find that and make sure it makes its way into the show notes.
Good.
I'm glad you mentioned SQLite. The whole time you talk about Postgres, I was like, surely this is going to end in SQLite, and yeah, perfect.
Yep. Yeah. So there's still a bunch of things that I would love to update on it. We have some people in the community also working a bit on Flamenco. I can only spend like 10% of my time on it, unfortunately. Like, the rest is all Animation 2025 project, working on animation and rigging tooling, which is also a fantastic project to work on. But Flamenco is getting a lot more traction now that it runs purely on your own hardware. It has no connection to the outside world. A lot more people are using it, and that is like really, really good to see.
That's fascinating in itself, like the psychology of open source free software and how you position things to be most used by your audience. It's very interesting. Quick editor pause here. Quick timing note. We are very close to the hour. Do you have to jump at the hour? Can I steal 20 more minutes of your time, or it's okay if you need to dip?
Yeah, we can keep chatting.
Okay, cool, awesome. Because I want to definitely get onto the architecture of Blender. So I'll just quickly squeeze in, go back to that accessibility point, because I know you do a talk on scripting for artists, so I wanted to touch on that because that was really cool, and then dive into how Blender, the software itself, is built, and then hopefully I won't end up keeping you here until 7 p.m. Okay, cool. So. Okay, so earlier on, you mentioned one of the really inspiring things about working on Blender is that, all kinds of people can use it. And, there's artists, there's 14-year-olds making movies, all this kind of stuff. And obviously your own background shows that as well with your using it as a researcher. What are some of the, the things that go into making what is a deeply technical project, supports Python scripting all throughout, accessible to, artists and these other profiles?
Well, yeah, like one of the things that we did is like what we have going on constantly is sharing knowledge. And that is one of the goals of like the existence of the studio to begin with. Like there is the studio.blender.org website where our artists pretty much on a daily basis like share their knowledge about how to do things in Blender, because they're on the daily build of Blender. So they really are on the cutting edge, sometimes the bleeding edge of Blender development. And not only do they help us to move Blender forward, but also once the tool is there, they investigate and they see how they can use it and what kind of crazy stuff they can do with it, and then share that knowledge on the Blender Studio website. So there's a lot of tutorials and practical information directly from the studio. Like all kinds of production lessons. And one of the training series that I made myself is scripting for artists. And like scripting things is very powerful, but also many artists don't want to become a developer. They don't want to learn to program, but also they don't want to do that mind-numbing, repetitive stuff over and over again. And that is basically where scripting for artists hooks in. So first lesson is copy pasting from the user interface, for example. Blender has a text editor where you can type Python code. You can press the play button, it runs that Python code. But what not many people know is that any button in the interface and any menu item, you can hover your mouse over it, press Ctrl-C, go to that text editor, press Ctrl-V. It will paste the Python code that runs that button or that menu item. Wild. Yeah. And so that's lesson number one. If you constantly have to click here, push that button, choose that menu item, push that, just copy paste that into a file. You have one play button that you can run it. And we take it from there. You learn more and more about Python and how it works. But I try to keep the learning how it works to a minimum and really focusing, okay, if you want to achieve this goal, like what are the things that you need to know for it? And I've heard good things about it, so people are happy with it.
Excellent. I still can't get over that. I'm now going to want that in every GUI application ever. That's absolutely I guess that's just powered by the Python API, and it's just knowing what the function invocation for each button is. That's just
so that goes a bit into like what is the architecture of Blender, and there is few different layers in there. At the very basic, it is what we call DNA.
Okay.
So it's the data structure of Blender. And every object, every mesh, every armature is a data block. It's like just block of data that is described by its properties and the type of those properties. And the DNA system is something that Ton actually designed already in the very first versions of Blender, and that is still in there. And so because the way it's built, it allows us to still open Blender 1.0 files that are like 30 years old and still open them in Blender today and get some reasonable output. Of course, the render engine that was there at the time doesn't exist anymore, so like you have to redo some things. But as long as we can bring it to the next version, we always do. And basically, what it is on a technical level is just a memory dump of Blender's memory. It just writes all those structs to the blend file with some meta information in there, like which struct type was it. That also contains which fields are there. It also stores where in memory that struct was stored. And that means that all the pointers can just be written as is.
Right, okay.
And there were pointers in memory, but now, because every data block has an annotation of this was its pointer, basically, it becomes an identifier for other data blocks in that blend file. So that is why saving in Blender is super fast, because there's no processing. There's no like converting into other data structures. It just writes everything as is to disk. And then when loading, it basically has to load everything once, and then it knows which pointers, like where those data blocks ended up in memory now. So it can go over all the pointers and just replace the old one with a new one, and it's done. So that is a bit about how Blender loads and saves blend files. There is more detail in there. Like it also saves which version of Blender that file was saved with. And so there is lots and lots of versioning code that says, if the version was older than this, then change this. Mm-hmm. And that means that if Blender changed from one representation to another, it can do that translation while loading the file. And then it's taken to the next thing. Or maybe we found that certain properties should never be used together. And so if that one's on, that one should be off. We can do that in versioning as well. All kinds of different things. And that allows us to just keep backward compatibility with older files.
That's very cool.
So that's the DNA structure. And that is what meshes are stored in, what objects are stored in, etc. Then on top of that, you have the RNA system. Both are from genetics. Somebody who knows about biology may not agree with the terminology, but it is what it is. And the RNA system provides like a more, basically the Python interface on top of the DNA structures. It can also reorganize things a little bit, so it can make some fake data structures that aren't really there in DNA, but makes the Python interface more Pythonic. And also this system is used by the animation system. So when you modify a property over time, that creates what we call an F-curve, because it's basically a function that maps from point in time to value of that property. That's where the F comes from. And this F-curve says, this is my path, A.B.C.E. This is my array index, number 1. And that could mean that the path is pose.bones left arm dot rotation Euler, and then first index, so that's number 0, and then you have the X rotation of that particular bone that is being targeted by that F-curve. And that again uses the RNA system to address that. So that also gives us a freedom to rename some things in DNA while keeping the RNA system the same, and so it doesn't break your animation, and still gives us the freedom to do things. And then you have a third layer, which is the operators. And the operators basically, now to go back to RNA for a little bit, like RNA can not just access properties, but also expose functions. So all kinds of operations on a data block you can model as functions in RNA. And that then maps to functions in C++ that get called with the right parameters. But there's also operators in Blender. And these operators can be defined in Python, but can also be defined in C++. And in the end, they register into the same registry. And they're basically functions that get called in specific places in specific ways. That maps to certain methods on a class that get called in the Python world. And these define when is the operation valid? When can you actually call this and when can't you? What is the label? What is the category it belongs to? And then that can be hooked up to panels and menus and all that kind of stuff. And so these operators are the glue between functionality in C or C++ or Python and the user interface. Menus, hotkeys also, they also map to just operator calls. Buttons in the user interface, again, just map to operator calls. And that is what you actually copy paste when you're doing the copy paste trick. You press Ctrl+C on a button, and that copies the Python code that is needed to invoke that operator. And that is roughly the data and operations part of Blender sketched out.
That's super interesting. I mean, as you said, maybe some PhD biologists will get mad at the DNA RNA usage, but when you were describing what the RNA system did, I was like, oh, that's such a good metaphor. That's great. That's awesome. Super interesting. So to stick to architecture for a little bit. So I guess the other architectural question I had, so, we mentioned that you work on the animation and rigging module. So, and I know there's, this idea of there's core Blender and then there's features in modules. what's the setup there architecture wise?
So it's getting better. Older, Blender really, in January, 2nd or 4th, I think 2nd of January. It's the 30th birthday of Blender.
Wow! Congratulations for a start.
It's still. Thank you very much. Thank you very much. It is still the same code base. So it is really interesting to sometimes fix a bug that might actually have been there since unknown long ago. I think the oldest commit that we have in Git right now is 18 years ago. Before that, versioning was different, apparently different enough that we couldn't bring that into the sequence of versioning systems that Blender has been in over the years. But you can imagine that things change, and when teams grow, the organization of Blender source code has to follow suit. So currently there isn't some distinction, though. Grease Pencil module, for example, really has their own files because those are the Grease Pencil files. That's relatively, in the history of Blender, Grease Pencil is relatively new. So that really has their own corner. Same for geometry nodes. That has its own corner in the source code. Animation and rigging, we're creating that, but it's still spread over a whole bunch of other files as well. Still within those subdirectories, there is a directory about animation with all the animation tools and editors, but the functionality is still scattered around pretty wildly throughout Blender. And we're taming that while we add new features. But so mostly it's about features in Blender or areas of Blender that relate to each other. So animation and rigging is there. VFX and the video sequence editor, I think, are one thing. Eevee and viewport, I think, is also combined into one module. And so every module has one module owner who can make decisions and who is responsible for what's going on in that module, which changes land and which are rejected, that kind of thing. And so, with the animation module, I became the module owner of that back in 2018. Then we were working on Blender 2.80 to get that out. And that was a very, very big amount of work. But it had to be done. And so for 3 months, we got a lot of Blender developers from all over the world into Blender HQ to work on the code quest to really get things done. And that was also where we looked at changing some of the modules, reassigning ownership. And then there was a question who wants to be module owner of animation? Back then it was just the animation module. So, me. And it was said that it's not that much time, and you just have to approve a patch every once in a while, and that's it. So yeah, I can do that. And then it became quite successful. So there was a lot of patches coming in. There was a lot of backlog because there hasn't been like somebody really focused on just animation. One of the first feedbacks I got from people was the riggers feel left out. So yeah, okay, it's renamed now to animation and rigging module. And we've been picking up the slack, and people were super happy to see that finally there was more motion going on and more momentum in the module. And I think now it's one of the more active modules in Blender, and we have like meetings every week, and for like 1 hour meetings to just get to show each other what we've been working on, but also discuss design decisions, to get feedback from all kinds of different animators and riggers, not just from people who are in the studio, but to have like a broader community where we can gather feedback from. And it really helps the developers to move forward, because you could just show, well, I'm thinking about this, but maybe it should be like that. And then you just can answer A or B. Okay, we go for that. And then you move on. And it really helps us to fly.
That's excellent. Yeah, I mean, that was going to be one of my questions. You know, this huge open source project, 18 years of commits, and I think I saw that you had 140,000 commits to Blender currently for 4.0.
Yeah.
And you know, you've got internal developers like yourself at the institute, and then FOSS contributors. You know, how does that work get organized? How do you when you're you know building up to a big release, or you know that you've got a next version of animation dropping, how do you prioritize work between what the community is working on and what they care about with what your internal roadmap?
So, well, for one, we try to keep the roadmap singular. So there's no internal roadmap of Blender HQ and then an external community roadmap. On the other hand of that, when there's a community developer who doesn't get paid for their time, you can't tell them what to do. They work on what they find interesting, and it's very personal what they find interesting, and so you have to deal with that as well, which can be quite a bit of a challenge, like somebody dropping something nice on your lap. But that doesn't fit in like where Blender is going. You have to see what you deal with that. That's a bit of a challenge, but it can also be very, very inspiring and very cool to see that what people are working on, what they're enthusiastic about. So we have a bunch of developers who work just part-time in their free time on Blender because they like it, because they want to help out, and it's fun to do in the evenings. We have some developers who work on a development grant. So the development fund is managed by the foundation. And like when people can apply for a grant, and then that is really for a set amount of time to work on a fixed amount of functionality. It's really like, okay, you're going to work for this many hours a week on this particular project with that as outcome, and then we can give you this. And that works quite well. Like one of our developers in our module, he is working part-time for a studio, and he is working part-time for us under a development grant. He liked it so much that he, instead of working 2 days for one, 2 days for the other, and 1 day in between having off, he's now working 3 days for us, and sacrifice his day off for us. So, and he is doing amazing work. And then there is people who are actually on payroll, and they're like employees of Blender Institute, or technically employees sometimes of a payroll company. I think we have a payroll company in Germany, for example, to work with a number of German developers. But that is more like regular being an employee of a company.
Yeah, absolutely. Awesome. So I know we're coming close to time, so I have a couple of, I guess, quick fire questions for you. So we've mentioned older versions of Blender a couple of times here today, but at the time of recording, Blender 4.0 has like literally just landed. Is there any features in 4.0 that you're particularly excited to see?
Oh, damn. A lot. That was actually Really fun to make the presentation for last year's Blender conference. That was end of October, so 4.0 was about to be released. And it was amazing looking back at the past year of the animation and rigging module work to see everything that we've done. So it's hard to pick out one or two things, but there's so many improvements that were made. It's hard to tell. Also, like for most of the world, like Blender 4.0 release is it's a big thing, and of course for us it's as well. But it's like such a continual stream of development that it's hard to remember what was in which version exactly.
No, that's perfect. We'll drop the release notes in the show notes either way. Do you have any tips for folks who want to get into contributing to Blender, who either experienced or coming at it completely fresh, never looked at a line of C++ in their life? What should they be looking out for?
If you don't know any C++, I would say, either learn it if you want, but that's like a decision that you have to make for yourself. Do I want to learn this? And then probably it's easier to just work on a few different C++ projects for yourself, because Blender is complex. And it is a mixture of C and C++. We're moving more and more code to C++. But most of that move means renaming the file from .c to .cc.
Right.
And making sure that things don't break when they're compiled by a C++ compiler instead of a C compiler. But many of the structures are still very C-like.
Mm-hmm.
So it's a hard, if you don't know any C++ development, it can be a very, very, how do you say, hard project to get into. And it can be very intimidating. Yeah.
What
I think most important thing I think is people. Connect with people. There's Blender Chat, Blender.chat. There's a channel called Blender Coders. That is like the main hub of communication of Blender coding. So if you have questions about like how does this work, what does this function do, you can just ask there. There's also technical documentation on the wiki, wiki.blender.org. We're moving that soon-ish to a new platform that will make things even clearer and easier to find, but that will be like in a blog post somewhere when that happens. But I think the most important bit is just connect with people. And every module has their own channel on Blender Chat. So if you're interested in certain topics, you don't have to dive into understanding all of Blender. You can just go into a channel that is dedicated to that topic and talk with people about what you can do. And I think that is regardless of whether you want to do the Python side of things or the C++ side of things. Connecting with the people that can help you out, I think it's the most important part.
Awesome. And then speaking of connecting with people, are there any Blender creators or animators in your community that you've got your eye on or would recommend to folks wanting to see what people are doing with Blender?
Oh yeah, there's a lot. So what I would say is, because there are so many, start by looking at the Blender conference. Like Blender conference last year was amazing, and we had presentations from people who worked on Spider-Verse, for example, on different areas. We had presentation of a guy who talks about doing a whole short film by yourself as a single person studio. There's always fantastic stuff in all areas of Blender. It's always mind-blowing. So I would say look at on YouTube. There's the Blender channel. There's the Blender Conference 2023 playlist in there, and that has all the talks that were recorded. So if you want to have a look out for people to follow, I think that's a very good start. Also, not all of them are on social media, or some here, some there. So it's hard to point at any one person, and I'd rather just point at this.
That works great. We'd love to put a huge conference playlist in the show notes. That's perfect. Well, Sybren, thank you so much. This has been wonderful. Thank you so much for joining us today.
Thank you for having me. It was a pleasure.